This afternoon, we are going to be talking about something that is very, very important and we see it around us every day. But before we go into the topic, let's share some previous knowledge. Now, the knowledge you need to know before coming to this class is you need to have knowledge of ions, radicals, oxidation number, and compounds. Therefore, what are ions? Ions are atoms or group of atoms that possess electric charge. And the example is hydrogen ion, while the radicals are groups of atoms that carry charge and behave as one entity. Example is tetraoxosulfate ion or SO42-. Now, what is compound? Compound is a substance which chemically combine together, and the example is HCl. Good. Now, behavioral objective. Meaning, at the end of the class, students will be able to define acid and base in terms of Arrhenius concept, Gross-Taylor concept, Lewis concepts, list types of acid, define natural and mineral acid, explain acid in solution, test for acid in fruits, and explain concentrated and diluted acids. Good. Now, acids and alkaline. All the substances shown below contain an acid of one sort or another. Acid are certainly found all around us. What property do these substances have which make you think that they are acids or contain acids? What do all these substances what do all these foods have in common? The word acid means sour, and all acids possess these properties. All acids possess these properties. They are also soluble in water, they are corrosive, and they have the ability to turn blue litmus papers to red. Now, let's quickly talk about two classes of acid. We have organic acid and inorganic acids. Now, what is organic acids? Organic acids are acids that occur as natural products in plants and animal materials. And a good example is what I've listed here with their source. Now, talk about the source. I will talk about the organic acids. Vinegar, we have ethanol. Ethanoic acid is present in vinegar. We have milk. Lactic acid is present in milk. We have lime and lemon. Citric acid is present in lime and lemon. We have amino acid. Amino acid is present in protein, while the fatty acid is present in fat and oil. And we have the ascorbic acid is present in our orange. It's present in our orange that we drink. Therefore, do you know, when you look at these particular pictures there, I'm talking about citrus fruits which contain citric acid. So their juice are acidic. This is shown here by the color changes on the indicator paper. Acetate sour. Look at this. It turns blue to red, it turns blue to red, indicating that there is a presence of acid in this particular lime and lemon. And the kind of acid we have here is what we call citric acid. Now, do you know that our stomach have lining that are much more resistant to attack by acids than our other tissues? Please, if you don't know, you need to know that our stomach have linings that are much more resistant to attack by these particular acids than other tissues. Good. Now, inorganic acid. What is inorganic acid? Inorganic acid or mineral acids are acids that are prepared from mineral elements or organic matters. When you're talking about mineral elements, element that has already been discovered, and you can find them in the periodic table. Now, I talk about inorganic acid, formula and constituents. Like hydrochloric acids, the element there is the mineral elements in hydrochloric acids are hydrogen and chlorine. In tetraoxosulfate acid, we have hydrogen, sulfur, and oxygen. These are the mineral elements that is present in this particular acid. And this particular acid is what we call inorganic acid. And when we're talking about inorganic acids, we say they are what? They are acids that are prepared from mineral elements, organic matters. Also, tetraoxosulfate, trioxonitrate 5 acid, trioxonitrate 5 acid. The constituent elements that are present there are, we have nitrogen, we have hydrogen, and we have what? Oxygen. These are the mineral elements that are present in all these particular acids. Now, acids in solution, what happens when you dissolve acid in water? Acid dissolve in water to produce what we call hydrogen ion as the only positive ion together with the corresponding negative ion. This process is known as ionization. Therefore, when we are talking about ionization, we are talking about the process of what? Generating ions, and which happen when acid is dissolved in water. Now, according to Arrhenius in 1884, define acid as a substance which produce hydrogen ion or hydronium ion as the only positive ion when dissolved in water. This is very, very important when dissolved in water. Whenever you dissolve a substances in water and that substances produce hydrogen ion or hydronium ions as the only positive ion, then that substance is called acid. And this is a good example of what is happening. The HCl here is a substance which we don't know if it is acid or not. But by the time you put it inside the water, what happens? It produces hydronium ion as the only positive ion. Because it does this, the HCl is an acid. And this illustration, this ionization reaction of this particular acid split into hydrogen plus, which is hydrogen ion, and what we call a corresponding negative ion. Here we have a chloride ion. Now, let's quickly talk about, there are three concepts of acid and base in current use. Each has its own peculiar advantages, and the student should understand all these three concepts. Yes, because by the time you enter university or you are furthering your education, you are going to come across all these particular concepts of acid. And it's good for me now to quickly introduce it to you so that you know that we can equally define acid. We've already done this before. We can define acid in terms of Arrhenius concept, Brostolori concept, and the Lewis concept. Now, let's take them quickly one by one. When we're talking about Arrhenius concept, I've told you that according to Arrhenius, Salvatore Arrhenius in 1884 proposed this concept of acid and base. According to this concept, an acid is a substance that releases hydrogen plus ion in water. That is hydrogen ions in water. And a base is a compound that releases hydrogen ions in water. And a good example is what we have here. For example, HCl is an Arrhenius acid, while sodium hydroxide is an Arrhenius base. Because when you have the HCl in water, it produces hydrogen ion as the only positive ion, and it produces chloride ion as a corresponding negative ion. Meanwhile, when you have sodium hydroxide, it produces hydroxide ion as the only negative ion, and the corresponding metals, which is sodium ion. Because sodium hydroxide produces OH minus as the only negative ion in water, therefore sodium hydroxide can be classified as a base. But we are going to talk about this, and this is what is happening. You have the water. What happened? This water, the lone pair, this pair of electrons from oxygen can be what? Donated to an empty share of hydrogen plus. To an empty share of what? Hydrogen plus. To form what we call hydronium ion. And you still remember, this kind of bond is what we call a dative. This is what we call a dative. This is what we call a dative bond, where one of the atom donates a pair of an electron to another atom, and this atom must have what? Must have an empty space or empty orbits or orbitals or shell to accept the what? The lone pair of what? Electron that is being donated by oxygen. And that is what actually happens when you release hydrogen plus. Hydrogen plus in water, hydrogen plus in water will now react with water to form hydronium ion. Now, according to Brustolari concept, an acid is any molecule or ion that can donate a proton. We are talking about a molecule or ion that can donate a proton, that is hydrogen ion, while a base is a molecule or ion that can accept a proton. Say one donating a proton while one is accepting what? A proton. We can say an acid is a proton donor, while a base is a proton acceptor. Now when you look at this story here, say according to Brustolari concept, in 1923, J.N. Brusted and J.W. Lowry independently proposed a broader concept of acid and base. According to this theory, an acid is any substance or ion that can donate a proton. A base is any molecule or ion that can accept a proton. We can say that an acid is a proton donor, while a base is a proton acceptor. Donate, this particular one is donating, see, to what? A base. Therefore, an acid qualifying Brustolari concept is termed a Brustolari acid, or a simply Brusted word acid. A base qualifying Brustolari concept is termed a Brustolari base or simple Brusted base. Now let's see what happened here. Wow, examples of Brusted acid and base. Let's see hydrogen chloride gas and H2O. When dry hydrogen chloride gas dissolves in water, what happens? Each HCl molecule donates a proton to a water molecule to produce what we call hydronium ion. And this is a very good example here. What happened here? The HCl, which is what I called hydrogen chloride gas, donates its own what? Proton or hydrogen ion to water. Because it's donating a what? A proton to water. We call this a what? A Brusted acid. Why water? Because it's accepting it. We call this one a Brusted base. Therefore, see what happened. It formed hydronium ion because it has already taken one what? Hydrogen ion from hydrogen chloride gas. Y itself becomes Cl minus. In this particular case, thus HCl gas is a Brusted acid, I've told you, and water that accepts a proton is a Brusted base. You see now, water can even behave as a base according to what? Brustolari concept. Good. So I can move on now. More example here, we have a hydrogen chloride gas and the ammonia. Now when you have HCl gas react with ammonia to form a solid ammonium chloride. Now see what happens. This particular one, it releases what we call, it releases hydrogen plus. That is the hydrogen plus that it has. To what? To ammonia. And because the ammonia has the tendency to accept this particular proton, what it forms? It forms ammonium ion. Why hydrogen chloride gas becomes Cl minus. Why? Because it has already lost the hydrogen here, the hydrogen ion that joined with it. Therefore, in this particular case, HCl is acting as a what? A Brusted acid, because it's what? Donating a proton, while ammonia is accepting the proton that is being donated by this HCl, and this becomes what we call a Brusted base. HCl is a proton donor, it's donating hydrogen ion, and hence is a what? Brusted what? Acid. Why is NH3 ammonium? That is ammonia. Is a proton acceptor and is called a brusted base. Now this is another example when you have calcium oxide and H2O. When calcium oxide is dissolved in water, it is converted to calcium hydroxide. Good. Here, a water molecule donates a what? A proton to oxide ion, which is O2 minus, and is a what? Brusted acid. And the oxide ion accepts a proton and give 2OH minus ions. Hence, is a what? A brusted base. What are we talking about here? As you see now, water too can act as an what? Acid. It can act as an what? Acid, because here is donating what? Is proton or the hydrogen ion to what? To oxide ion that is formed from what? Calcium hydroxide when dissolved in water. And when it accepts this particular proton, it becomes what? It produces what we call 2OH, that is 2 hydroxide ions in water. Because it's accepting a proton from water itself, this hydroxide becomes what we call brusted what? Base. While this one is giving it, the water becomes what we call a brusted acid. Therefore, the reaction between calcium oxide here can react as a what? A brusted what? Base, while H2O here can react as a brusted what? Acid. Good. Now the definition of acid according to Lewis concept. Now let's quickly talk about this. The Lewis concept of acids and base. In the early 1930s, G.N. Lewis proposed even a more general model of acids and base. According to Lewis theory, an acid is an electron pair acceptor. We need to understand what we mean by electron pair acceptor. While a base is an electron pair donor. When I say electron pair, we have 2 electrons sending it to another what? Substance. Here is a base. While a base is what? Base send it to what? Acid. Because here we say an acid is a what? Is an electron pair acceptor. While a base is an electron pair donor. Donate a what? A lone pair to what? Acid. And acid accept that. And when it does that, it becomes an acid, while this one becomes a base. Lewis picture an acid and a base as the sharing of electron pair provided by the base. Now it is the base that is providing the what? Electron share and donating it to the what? Acid. This creates a covalent bond or coordinate bond between the Lewis acid and the Lewis base. The resulting combination is called a complex. This is how we form a complex compound. If the Lewis acid be denoted by A and the Lewis base by B, then the fundamental equation of the Lewis theory can be written as follows. Now, according to the definition of acid according to Lewis concept, an acid is a what? Is an electron pair acceptor, while a base is an electron pair donor. Now, this is a good example of what I'm trying to say. The base must have a what? A lone pair. We call it electron pair. Must have 2 electron pair to what? Donate to the what? Acid. Then the acid must have what? An empty what? Orbitals to accept this lone pair of electrons to form what we call a complex. If this happens, then we say B is a Lewis what? Base, while the A that is accepting the lone pair of electron is a Lewis acid. Now, let me quickly explain the examples of Lewis concepts. Good. Examples of Lewis reaction. 1. Between hydrogen ion and the ammonia. A proton, which is hydrogen plus, is a Lewis acid as it can accept an electron pair, while ammonia molecule. I told you this, it has hydrogen plus is like this. Is in these orbitals, there is no electron. Therefore, it can accept 2 electrons. Yes, That's why we say it's a Lewis acid, as it can accept what? An electron pair. Why ammonia has what? Ammonia has what? A pair of electrons that it can donate to hydrogen plus. Has an electron pair which it can donate, and it is a Lewis base. Thus, the Lewis reaction between proton and the ammonia can be written as, look at it, this is a Lewis base because that's a lone pair of electron. Why the proton or the hydrogen ion has a what? An empty shell that it can, an empty orbital shell that it can use to what? Accept electron pair that is being donated, that is being what? Donated by the base. Therefore, this one becomes a Lewis base, while this one becomes a Lewis acid. Equally applicable here, yes, in case of ammonia. Therefore, when you have something like this, Al6, when you have something like this, or you have AlCl3, this is forming dimer. Here is dimer. No, this kind of, here, look at it, hydration of hydrogen. Clearly, what happened? The hydration of the metal ion, such as what? Aluminium, is also a Lewis what? Reaction. Because this particular metal, what happened? It creates what? Empty what? Orbitals. Which what? The chloride ion here can what? Donate what? A pair of electrons to it. And when that happens, it's from a complex ion. And this complex ion is what we call a dimer here. This kind of bond, this kind of AlCl6 to, it is an acid because although it doesn't contain what? Hydrogen plus, but it is an acid. Why is it an acid? Because it has the what? Empty orbitals that it can use to what? To accept a pair of what? Electrons. And see, when you dissolve this in water, see what is happening here. See what is happening here. The water here, look at this water here. The water here is having two lone pair of electrons. Then the electron is being what? Is being donated to the what? To the metals, because the metal is having what we call free orbitals that it can use to accept the electron. And when it happens, what happens? It's formed what we call a complex compound. Therefore, you need to understand that according to Lewis, an acid is a what? Is a electron pair what? Acceptors, while a base is an electron pair donor. I think okay. I think we can stop there for now. Then in the next class we are going to continue from where we stop. Here we'll be talking about water can act as both as an acid, so I'll be able to explain why water can act both as an acid and a base. I hope you enjoy it. If you do, please, I want you to subscribe for more video. I'm begging you. Thank you, and bye bye for now.